Okay, so the first question is how to modelize a gas turbine to calculate the clearance in the compressor and turbine section. So the most important concept here is the tip clearance. This is the distance between the shroud and the blade. And it's really important in the overall efficiency of an engine because it's one of the causes with other three of losses in the blade. So the first one is the profile losses. Those are caused for, like in a wing, separation of the float in the profile. Also the choke losses. The wall losses is because of the vortex between the, I will try to, between the vortex generated between the traction of the blade and the disc. And the important for us is the tip leakage. This is caused because the difference in pressure in the fluid will tend to generate vortex at the tip. So in the literature they say that 1% of increase in the clearance of the tip will decrease in 1% the overall efficiency of the turbine engine that is related with the specific fuel consumption, and is also related with the specific fuel consumption. So to modelize this, I think we need to modelize the blade. I will draw it like that, but also to modelize the shroud. We need to know the dilatation of both materials, so we need to know the change in the temperature and the properties of each material, the material of the blade and the material of the shroud. Also, I know the engine casing and the shrouds are connected with hooks or this type of hangs. So to modelize both, we can try to find relation between, for example, this length and the distance with the axis of the engine. So if we find a relation between L and R1 with other engines in the literature or other old engines that we already developed, we can find relation and try to modelize those relation to find yes, like a formula to relate those parameters. Even we can do the same with all the geometric parameters in the shroud or the engine housing. And then that is the first part, and then we can use the formulas for dilatation of materials to find the dilatation in each section of the flight, because we can know the temperature and the rotation speed of the tip, and we can calculate the dilatation of the blade and also the dilatation of the shroud to know the tip clearance in each instant, and like that we can optimize this distance to the for the mission profile of the engine.